Hello and welcome to Arithmetic Sequences, our new set of notes. So for today, since it is kind of our first official new thing in our unit, just kind of take it pace by pace. It is going to be 5 pages of notes. So just give it a little bit of time to kind of let it sit, learn through it and all of that. So here we go. A sequence, first of all, we have to figure that out. It is an ordered list of numbers that follows a pattern. So we do have new notation, a sub notation. So we have and function notation. Function notation is not new, but we will use these interchangeably. So how we say this first one is a sub 1. And so what this represents is it's your first term in the sequence. So like a sub 2, second term, a sub 3, third term, and so on. And so when we get to this thing called a sub n or f of n, this represents the nth term in the sequence. So just some random term. So some examples of sequences are these below. So for this one, we see, we add 4 every single time to get to the next set of numbers. And so if we followed that pattern, the next set would be 19. Our other list of numbers over here, we see that we are dividing by 2 every single time. Now, another way to think of dividing by 2 is multiplying by 1/2. The reason I bring that up is when we talk about a different type of sequence, it'll be very important. But they do the same thing, and so the next term in our sequence, using a calculator, obviously, would be 0.625. Now, those are two types of sequences because they follow a specific pattern. We're going to be looking at a specific type of sequence where between any two consecutive numbers there is a common difference. So this is an arithmetic sequence. I always think of adding or subtracting. And so this right here, this is an arithmetic sequence. And so we can find our common difference. There's 2 ways. We can do it like we did up here where we just said, how do we get from 3 to 7? We add 4. The mathematical way is where we take our second term, so 7, and subtract it from our first term. That's 4. We can keep doing it. Our third term is 11, minus our second term is 7. And if we keep doing that, I'm going to subtract this, we would see that our common difference is 4. And so that would create our common difference. We're going to kind of skip this. What we're going to do now is we're going to look below and figure out if these are arithmetic, and if so, we're going to state the common difference. So we can do it again 2 ways. We can see our second term minus our first term, which is -1 minus 4, which is -5. And then take that and ask yourself, do we subtract -5 every single time? Yes, and so this makes it an arithmetic sequence. And so our common difference is -5. Now it's just a little bit faster to see, hey, let's look at number 2. Are we adding the same amount each time? Well, we add 2 here and then add 4. So because those are different, this is not arithmetic. It has to be the same. So let's look at number 3. To figure out if it's arithmetic, we would see, this one might be a little bit difficult. So again, you always have that a sub 2 minus a sub 1 to find your common difference. So 4 minus 1.5 is 2.5. And so our common difference we're thinking is 2.5. Does that pattern keep happening? Yes. If it does, that means it is an arithmetic sequence. And our common difference is 2.5. Okay. Now what we're going to do is we're going to look at 4, 5, and 6 and write the first 5 terms of the sequence. So this right here, this is our first term because it's a sub 1. So we're given our first term and we have our common difference. So we need to find 4 more numbers. Our common difference is -2. So we're going to just subtract 2 every single time. So 6 minus 2 is 4. 4 minus 2, 2. 2 minus 2, 0. 0 minus 2, -2. And that would create our sequence of numbers for our first 5 terms. Let's look at number 5. So we have our first term and our second term. So 3.5 and then 7. So that means we need to find the next 3 terms of the sequence. So we're not given our common difference directly. We can find our common difference by taking our second term and subtracting our first term to see, oh, we're adding 3.5 each time. And we can check, oh, add 3.5, so 7 plus 3.5, 10.5. 10.5 plus 3.5, 14. 14 plus 3.5, 17.5. Okay. Number 6. So for this one, again, we're given our first and our second term. So we have 2/5 and then -1/5. And we're asked to find the next 3 terms. So you might be able to see it, but I always like to remember my common difference formula. Second term minus your first term. It's coming from our slope form, our formula for slope for 2 points. We'll talk more about it next class or later in this video. But anyways, getting back to this, we would get -3/5. And so we can see, oh, we're always just when we subtract from fractions, we're subtracting from our numerator. So for this one, -1 minus 3, -4/5. -4 minus 3, -7/5. And then from here, I'm going to write it up here. The reason is -7 minus 3 is -10/5. Well, we can simplify that one to -2 to create our first 5 terms in our sequence. So now that we've seen that, let's look at the next page for problem number it should be 7, and asks, what would the second and fifth terms be of this given sequence? So again, if we know that it's an arithmetic sequence, we know that there's always a common difference. And so it can happen between any 2 consecutive numbers, which we do have. So from -6 to -11, we subtract 5. So if we do that to find our missing terms, we would get -1. Well, look at that. -1 minus 5 is -6. So then -11 minus 5 is -16. And so that's how we get our next 2 terms, or our missing terms. Now, this is all leading up to being able to create this thing called an explicit formula, where a sub n is the nth term, a sub 1 is your first term, and d is your common difference. Later in the video, we will see why we do n minus 1 later in the video. For right now, let's just kind of explore using that arithmetic sequence. We will need to simplify our explicit formula. What's kind of cool is that it will end up looking like this equation for slope-intercept 4. So let's kind of see. So we need to find our first term. We then need to find our common difference. So that takes a little extra work. So for number 6, we are adding 3 every single time because we always want to make sure that it's arithmetic. And that would be our common difference. So now what we're going to do is we're going to plug it into that formula. A sub n, that's always going to be there, equals our first term plus our common difference times n minus 1. Now that's not our final answer. We need to distribute to get 1 plus 3n minus 3. and finish by combining like terms. 3n minus 2. And so, let's fix that. That is our explicit formula. Okay, that's all we're doing. And if you notice, it's very similar. This is our m, and this is our y-intercept. And, I think it's on the next page. Yes, on our next page, we'll see it a little bit more in depth. But let's go over number 7 together. So we have our first term, our common difference. We're subtracting 4 every single time. And so our d value is negative 4. So a sub n equals our first term plus our common difference. Well, adding negative 4 is just subtracting 4. I'm going to distribute in to get 6 minus 4n plus 4, and then combining my like terms to get my final answer. And then I'm going to bring down that a sub n to complete my equation, my explicit formula. Okay, so now what we're going to do is the whole purpose of finding this explicit formula is it will work for any nth term. So you could do 5, you could do 20 in this case. We really don't want to sit here and take our common difference and add it 20 times. So instead what we do is we find our explicit formula and then we plug in 20 for n. So we have our first term. Our common difference, we're subtracting 5 every single time. We always want to make sure that happens because it is possible that we don't have an arithmetic sequence and we can't write our explicit formula for it. Later in the video, I will talk about how you can actually find your explicit formula and skip all this work. But it's good to see where it's coming from. So we have 7 minus 5 times n minus 1. I'm going to distribute that 5 in to get 7 minus 5n plus 5 and finish by combining like terms to get negative 5n plus 12. Now, you do not have to write it in this form. You can switch it around to be 12 minus 5n. That is perfectly fine because I'm not asking for it in slope-intercept form. I just write it like this because to me, it just makes more sense. So now we're going to find our 20th term. So this means that we are going to be plugging 20 in for n and solving. So we would end up with negative 100 plus 12, which will give us a sub 20 equals negative 88. And that's how we would write it as a math sentence. Okay, so let's now try number 9. So for number 9, again, we have our first term. We see that we are adding 12 every single time. If you second guess yourself, again, you have access to that calculator. Use it. So our first term plus our common difference times n minus 1. Distributing in gives us 5 plus 12 and minus 12. Finishing by combining like terms will give us 12 and minus 7. And again, we can't forget that a sub n. You can also use function notation. I'll use it on the next problem. And so, or the next piece of this, we are asked to find f of 20. So this means all we're going to be doing is plugging in 20 for n and solving. And so, it is 12 times 20 minus 7 is 233. Ooh, there we go. Having troubles. And so there is our final math sentence. For your notes, I'm going to cross out number 10 just because it gets a little difficult, but number 11 is really good. Now, there's a lot of ways that you can go about finding this problem. I'm going to show the algebraic side of it in this video right now. So we need to remember that, well, first of all, directions. Woo! Find the explicit rule for the nth term of the arithmetic sequence. So we're finding our explicit rule, which is right here. So I'm just going to bring it down to kind of help set it up. So a sub n equals our first term plus plus our common difference times n minus 1. What we're given is we're given f of n. We're given that n is 10, and we're given our common difference. So what I'm going to do is I'm going to plug all of this in. Now again, function notation and a sub notation, you can use either one. So we're finding f of 10 is our first term, which we don't know, plus our common difference, times, well, we do know what n is, 10 minus 1. Well, we also know that f of 10 is 38. So I'm going to substitute that even in more. So 38 equals a sub 1 plus 4 times 9. Well, 4 times 9 is 36. And so what I'm doing is I'm solving for a sub 1. I see that my first term in my sequence is 2. Well, that's not done. We needed that because we needed to know what our a sub 1 term is to write our explicit formula. We need to know where we start with. And so now we have it, we can write our explicit formula, distribute the 4 in to get 2 plus 4n minus 4, combining like terms to get 4n minus 2 is our explicit formula. Okay, we'll talk more about that in class, but let's look at the graph of it. So this kind of shows why we have n minus 1. I'm going to use my highlighters right now to kind of show it. I'm going to color code it. So we have our first term, which is 2. Okay, and so we haven't added anything. We then get 5 as our second term. And so what we do is we take our first term and we add 1 3. That's how we get 5. In our third term, we take our first term and we add 2 3s because we've done 1, 2, 3, 2 common differences. And that's how we get 8. For our fourth term, we took our first term and then we added 3 3s to get 11. So for our fifth term, again, we start with our first term. Well, we can kind of count. 1, 2, 3, 4. So our fifth term has 4 3s added together. And so 2 plus 3 times 4 is 14. And so you hopefully are seeing a pattern that we are always taking our first term and adding, we're going to add, oopsies, I didn't color code this. So 1, 2, 3, 4, 5. So our sixth term has 5 3s being added together to get 17. And so our seventh term, you might have guessed it, we take our first term and we are going to add 6 3s. So plus 3, plus 3, plus 3, plus 3 to get 20. And so what we're seeing is that we take our first term, we add it to 3 times our term minus 1. And that's where that n minus 1 comes from. So when we graph them, we're going to be looking at our term, our n value and our term. And so our n value is going to be our x's and our term is going to be y. So 1, 2, 2, 5, 3, 8, 4, 11, 5, 14, 6, 17, and 7, 20. So there's something interesting going on with our graph. Notice how I did not connect it. That's because it's going to be discrete, because we do not have like 2.5 terms. We have 1, 2, 3, 4 terms. It's also linear. It's also a function. It's also all positive. There's a lot of stuff that you can see. What's also cool is if we found the slope, so we go up 3, right 1, And so our slope for this is 3. Well, our common difference was 3. So what that means is, again, slope is the same thing as our common difference. And so if we use that idea, so if we go backwards, go down 3, right 1, we would end up at -1. And so what's kind of cool is that your a sub 0 term is your b value. But we're never given our 0 term. We have to do some extra work. So let me kind of show you how that shows up. So let's actually write the explicit formula for this term. So we have, I'll do it right here. 2 plus 3 times n minus 1, that's our explicit formula. We're going to distribute that 3 in, and then combine like terms to get a sub n equals 3n minus 1. And so our explicit formula is 3n minus 1, which, look at that, our slope and our y-intercept. So y equals mx plus b. That's why we're learning arithmetic sequences in this chapter, is because an arithmetic sequence is a linear function and they look almost identical. Again, the only difference is we do not connect our points. So we're going to cross out number 4. Let's try number 5. So we're going to do the long way here. So actually not, we're not going to do the long way. I'm going to show you the shortcut, okay? So our common difference, we are subtracting 4 every single time. And then our first term would be 142. Well, if we want to find the y-intercept or the 0 term, we're going the opposite way. So that means we're going to add add 4 to 142, so 146. So that'd be my 0 term. So I'm going to leave that right here for a moment, and I'm going to kind of do some, I'm going to do work of finding my explicit formula. That's where we take our first term plus our common difference, so minus 4 times n minus 1. We're going to distribute in to get 142 minus 4n plus 4, that's where that plus 4 comes in, to get negative 4n plus 146. And so our explicit formula is a sub n equals negative 4n plus 146. And lo and behold, our common difference is our slope in a sense, and our 0 term is our y-intercept. And so if you don't get it, do this. It will work every single time. This will also work every single time. You just got to be careful. There's more places to make mistakes. But now that we have our explicit formula, we can find our 10th term, which is negative 4 times 10 plus 146 to get negative 40 plus 146, which is 106. And so this one used function notation, but same rules apply. So there's our answer. Okay, I'm going to show the shortcut for B. So all we have to do is first find our common difference. So we are adding 3 every single time. Oopsies, obviously. There we go. And so to get my 0 term, I'm going to go backwards. So instead, I'm going to subtract 3 to get negative 8. And so we'll write in function notation. F of n equals our common difference, also known as slope, plus my y-intercept, which is my 0 term. And there we go. And now what we can do is we can plug in 10 into our problem. And so 30 minus 8 is 22. And so 22 is our 10th term in the sequence. Okay. So what we're going to do is we're actually going to cross off the last 2 problems here, 6 and 7. What you are going to do right now is you are going to do problems 1, 2, 3, 4, and 5. I want you to do these on your own. You will be uploading these to Google Classroom, but we will go over them in class next time we meet all together. But I do need you to do on your own and upload with all the other stuff to Google Classroom. Come with your questions and we will go over everything.